Hey everyone, today we are live, period 2 geometry. We're talking about kites. Yesterday we did some trapezoid stuff. Today is our last quadrilateral, dealing with something out of a Mary Poppins movie. So, a quadrilateral has two pairs. Um, I'm sorry, with kite is a quadrilateral that has two pairs of consecutive congruent sides. However, the opposite sides are not congruent. Which is a little bit different than any of the other quadrilaterals that we've kind of talked about. If you notice, what it means by consecutive is the two sides that are right beside each other are congruent. Okay? It's not the opposite, as we've seen before. Vertex angles, the angles are between the congruent sides of the kite. Okay? And then the non-vertex angles are the angles between the non-congruent sides. We've got a couple kite theorems as well. This one states that if a quadrilateral is a kite, then the diagonals are perpendicular. Very similar to what you've seen with a square or a rhombus. And if a quadrilateral is a kite, then exactly one pair of opposite angles, the non-vertex angles, those are congruent. As you'll see from the picture. Okay. So, what's the easiest way to remember some of the properties of a kite? A kite has those consecutive sides, perpendicular inside, and then opposite angles. And you'll see with a kite, it'll look very, very much like it's like a square that is stretched, or even like a rhombus that is just quite stretched. So let's take a look at this example 6. It says, find the missing variables using the properties of theorems in kites. One of the things that we have to kind of show here is that if we have this whole entire, let's take a look here, is if this is 50, okay, W will also be 50. The reason that this occurs is because the whole entire angle will also be congruent to this whole entire angle. So 60 with 60, 50 with 50. We can also tell, too, based on some of those properties that we've seen, that these are all 90-degree angles. Just make one giant square. So y is going to be 90. Those are probably two of the easiest things to see within a kite. Now to talk a little bit about x and z, you almost have to draw the triangle out itself. So you don't have to do this, but I'm just kind of going to show you. If I just drew that smaller triangle, I've got a 90-degree, a 50-degree angle, and x. There are 180 degrees in that triangle, so I take 180 minus 90 minus 50, and I'll end up with 40 degrees. And then the same exact thing here. If I drew out the back part of this, this is 60, this is 90, and then I need to find z. So 180 minus 90 minus 60 gives us 30. Find the missing variables using the properties and theorems of a kite. It's very similar to what we just did. Now we're just involving a little more than just an x, y, or z. So let's kind of dive into what we know in order to solve first. Some things that we might want to put down here is that each of these is 90 degrees. This is going to be 35. And we can kind of slowly start to at least form and find out what y is going to be based on what we did on the last problem. So y would be equal to 180 minus 90 minus 35, which would end up giving us 55. Let's see here. What else can we know about kites based on our properties? Let's take a look back here to talk a little bit about some things that they said. It said if a quadrilateral is a kite, the diagonals are perpendicular. We've got that. If quadrilateral is a kite, then exactly one pair of opposite angles would be congruent. So what we can also tell is if this is 55, then this is also going to be 55. So right now we have a quadrilateral that has a 110, it looks like 110 degrees there. And then we're trying to figure out the rest of the pieces. Can anybody else see what the next piece might be that we could figure out? Well, if we know that these are congruent, what else could occur? Alistair?
We could do 180 is equal to 4x plus 40 plus 2x minus 10 plus 90 to get WZ.
Okay, good. Yeah, let's start with the x first. So Alistair said that we've got 180, because if we look at this smaller, let's look at this smaller triangle. 180 is equal to 90 plus 4x plus 40 plus 2x minus 10, since they gave us all those x values. So now we have 180 equals 190 and 40 is 130 minus 10 is 120 plus 6x. Subtract 120. So 60 is equal to 6x, and then x is equal to 10. This helps us because this would then become 20 minus 10, 2 times 10 minus 10, which would give us 10. And then this would also be the case over here as well. This would also be 10. Up here, we then have 40 plus 40, which gives us 80. And if that's the case, then z would also be 80 as well. Okay, questions at all on example number 7? All right, now let's do the very last one that we have here for the video. Find the missing variables using the properties and theorems of kites. This one has a little more than just the angles. It's also dealing with some of the outside measures. So first off, take a look at these markings. We know that those mean congruent, so we can find x. 15 is equal to 4x plus 3. Subtract 3. We get 12 is equal to 4x. Divide by 4. Then x is equal to 3. So here's something for you too to kind of note is down here we also have these markings as well. That means that both of these sides are congruent, which means that this one is also 27. It wants us to find that middle blue line, that whole entire blue line that it's looking at. In order to do this, I think one of the things that we can do, it just wants us to find from here to here, I think it is, the proportion, is if we know that this is 24, then this will also be 24 as well. And we can now separate this using Pythagorean theorem. So we could say 27 here, 24, and then 12 times 12x plus 5y. Really 12, this will be 12 times 3. So 12 times 3 plus 5y, or 36 plus 5y. That seems like, I'm gonna do this, but it just seems like quite a bit for this type of problem. Can anyone else think of a different way to solve this other than using Pythagorean theorem? Okay, let's go ahead and solve. So we're going to say that we have 27 squared is equal to 24 squared plus 12x plus 36 plus 5y squared. I'm going to start by solving 27 squared and 24 squared to see if there's some like little trick that I can do where I might not necessarily have to FOIL. So 27 squared is going to give me 729. 24 squared is going to give me 576. And then I'm just going to leave this 5y plus 36 squared here for now. It doesn't necessarily look like I'm going to be able to do anything crazy with this. And maybe I'm missing something and I'm just drawing this out. But this looks like it would be 153 equals 5y plus 36 squared. I'm going to take the square root of both sides in order to get rid of my square. And I'm going to get approximately 12.4 is equal to 5y plus 36. .4 minus 36 is going to give me negative 23.6 divided by 5. And it looks like y is going to be negative 4.72.